soda stream machine ready here. We're going to test some water today. We're also going to make some carbonated water. Let's take this water here that's from my tap, and I'm going to add some universal indicator to it. All right, so here's the different colors that universal indicator displays. Whoop! Let's pop that up there, see if we can get that nice and back. Oh my goodness, what's going on today? There we go. Those are the colors we would expect universal indicator to display in acid or base. I'm going to add some universal indicator to this water here. We're going to see what color it changes. This is water from my tap. I just put it in a soda stream bottle. Let's give it a little squirt. You'll see that the universal indicator is green. We add it to the water from my tap. Oh, it's kind of green to me. What do you think? Huh? Yeah, that looks green. Let's check the pH level, okay? So we know this stuff is green. Let's check our pH. That's neutral, baby. So the water from my tap is neutral. I'm going to go ahead and I'm going to pump some carbon dioxide into this using the soda stream machine. I'm going to play around with that. Pop it in here. Got that nice green color indicating neutral pH. Give it a little pump of carbon dioxide. Here we go. Well, that's kind of cool. It looks kind of orange, doesn't it? Orange-red. Give it another pump. Interesting. Look at that. You can see that nice red color. What's kind of interesting up there at the top, it looks a little bit more yellow. This is where the carbon dioxide has escaped a little bit. Let's look at those colors. Looks like the water is like pH 3, which is quite acidic. Up here where the carbon dioxide is escaping, it's a little less acidic, right? It's like kind of yellowish in color. So up there it's about pH 3. You can see, though, that when I pump the carbon dioxide in, the water became acidic. That's kind of cool. Now watch this. Check this out. Let me get that cleaned off. I don't use this for drinking, by the way. This is just for experiments. Okay, we've got our carbonated water, that you can obviously tell is low pH. I'm going to pour some of this into this container here. Just a little bit. All right. We're going to leave this water over here as our control. And then what I'm going to do is I'm going to disturb this water over here on the right. And by doing that, by disturbing this water here, when I do that, the carbon dioxide is going to come out. You can see it a little bit as it bubbles. And when the carbon dioxide escapes, well, since carbon dioxide going into water makes the water more acidic, it stands to reason that carbon dioxide coming out of water should make the water less acidic. So as I do this, you might see a color change. That might become a little bit more orange than red, and I can actually see it happening. I don't know if you can. Yeah, let's turn these lights on here in the back, see if that helps. I don't know, does that help or not? Man, those almost look the same color, don't they? Those are pretty close to the same color. Let's keep going. I don't know. It looks kind of like a different color to me, but it may just because that's what I want to see. Let's keep disturbing this. Let's see what that looks like. That's looking more orange to me. Oh yeah, I see a color difference. That looks a bit more orange. Yeah, the water that has disturbed out of it. That looks more red, baby. Now up at the top, you can see sort of the foam that has a little more yellow color. How you doing there, Angela? Let me go ahead and maybe I'll pour some of this into a cup so we can sort of see it. I'll try not to disturb this one. I'll try to really gently pour this in so that the carbon dioxide will hopefully stay in. Maybe we can see a color difference there between the two. Between the one that has and has not been disturbed. Oh yeah, I see a slight color shift. This one's a little more red than this one here. I'm going to disturb this one just a bit more. Just a bit more. Interesting. So there you have it. Slight color difference. Angela, I was pumping some carbon dioxide into water and watching the color changes that occur. Oh yeah, we were doing some science stuff for sure. You can see a slight color difference between these two. Certainly can see a difference between this one here as well. Okay, let's do this now. Let's test some water. Let's test some different brands of water, see what their pHs are. Let's do this here. Let's show you a bunch of different brands of water. Let's do like Aquafina. Oh, we'll do a Dasani. We'll do Evian. What's this? Ice Mountain. And something like Icelandic. Here we go. Let's get all these up here so you can see what we're going to test here. We're going to test all of these. See if all water is the same or if they're different. All right. Look at all those brands of water. We've got Evian. We've got Icelandic. We've got Aquafina. We've got Ice Mountain. And so we can get a little bit, another one on here. We've got Dasani. And what I figure we're going to do is we're going to test all of these with our universal indicator to see what their pH values are. And that'll give us a little bit of an indication of how many minerals are in them. We'll talk about that as we go through it. Okay, so let's do Aquafina first. We're going to do Aquafina first because if you notice Aquafina, it says it is pure water. Actually, it's purified. It's not quite completely pure. It's purified water. It's purified through reverse osmosis. So this is kind of like our control. So let me go ahead and take the Aquafina water. We're going to open it up. And I'm going to add the universal indicator to it. The universal indicator shows these different colors at pH values. So if it's perfectly pure water, we'd expect to be neutral at pH 7. So in goes the universal indicator. Right here. It's nice and green color. But check out what happens when it goes into the Aquafina. It starts out looking like it's green, but then it gets into the Aquafina and it's got like this orange color. What the heck is going on there? Look at that. That definitely looks orange to me. Let me shake it up so you can see it. So yeah, the purified Aquafina has an orangish color. That's like pH 5, man, pH 4 or 5. Why is the pH so low? That's because any water that's been purified, that's exposed to the air, will have carbon dioxide dissolved in it. And just like I showed you with the soda stream, when carbon dioxide goes into water, it makes it acidic. So this water isn't completely pure. It's been purified, but because it is it's been exposed to the air, there's going to be some carbon dioxide in it. So yeah, so that's why this is going to have a low pH. Now what they normally do, like with Dasani, they say, look, it's purified water, but it's enhanced with minerals for taste. See, most people do not like the taste of pure water. It's got like a little bit of a sharp taste to it, and some people notice that. So what they do is they purify the water to get any of the junk out of it. That could be, you could pick up, like lead and other minerals from the ground or whatever. So they'll purify it, and then they'll add some minerals back for taste. Now we're going to see the difference here. So this Dasani water has indeed been purified, but minerals have been added back. So this one is purified Aquafina with no minerals added back. Dasani has minerals added back. So even though Dasani does have some carbon dioxide from the air dissolved in it, the minerals, look at that, the dissolved minerals make it so that the Dasani is not quite as acidic as the Aquafina. Let me give this a shake so you can see that. So yeah, the Aquafina is like, man, it's like pH 4. This stuff, that's more like a pH 5 or 6. Here, let me show you. Yeah? I'm going to give that like a pH 5 or 6. I don't know. Maybe you think it's 5. Maybe you think it's 6. But that's the difference between these two. Even though they have both been purified and carbon dioxide has dissolved in both of them, which makes them slightly acidic, the minerals added back to the Dasani makes it slightly less acidic. And that's why its pH is not as low. So, Aquafina is down here like pH 4. The The Dasani has some minerals, and that brings it closer to pH neutral. Now we can check out some of these other. Now we can check out some of these others. Let me do this first. Hold on a second. All right, we are going to try. What do we want to try next? Hello there, Radden. I think I'm going to try Ice Mountain next. All right, we'll try some Ice Mountain. We'll try this one next. Let's see what this one. This is natural spring water. It's funny, it says 100% natural spring water. Whatever that means, honestly. I guess it just means that all the water that's in here came from a spring. But it's not 100% water. Let's see. I'm going to go ahead and add. This has a lot of added minerals. I shouldn't say added minerals. It's just minerals from the spring. And what's nice about that, this pH is going to be even higher. Check this out. Look at that. We got 3 different waters, and all of them test different with the universal indicator. That's like a nice green color, isn't it? Yeah, let's put that one front and center. 3 different waters, 3 different colors. Yeah. This one's kind of like right there at pH 7. So the Ice Mountain has enough minerals in it that it's able to neutralize the carbon dioxide. So Aquafina, which is completely purified, nothing added back. Of course, there's carbon dioxide from the air that gets in it. That's going to make this slightly acidic. I can do that right next, Radden. I can do the tap water next. We can do Aquafina, pH 4. The Dasani has some minerals added back. That gets us to pH 6. The Ice Mountain probably has even more minerals added back. That gets us all the way up to pH 7. So, folks want to see my tap water. By the way, tap water varies wildly. Hello there, Phantom. I've got some tap water in this bottle right here. You're welcome, Radden. We're going to test the tap water. We'll do Evian in a second. We'll do Icelandic in a second. But right now, we've tested Aquafina. We have tested Dasani. We've tested Ice Mountain. And now it's time to test my tap water. Put the Ice Mountain back there so everything can get on the platform. There we go, baby. Okay, let's test my tap water. Which you got to remember, everybody's tap water is different. So just because my tap water is going to show a certain result does not mean that yours would. Here we go. We're going to add the universal indicator. You can see it starts green. I'm going to give it 2 big squirts here. And it looks like my tap water, you can see it's green, but it's got a little more yellow tint to it than the Ice Mountain. So I'm going to say that this is, well, it's green. It's like a yellow green, yeah? So it's somewhere between pH 6 and pH 7. So we're going to call Ice Mountains green. Yeah, Ice Mountains green. This one's kind of a yellowish green. And, of course, Dasani and Aquafina are slightly acidic. So Radden asks, is your tap water better than Dasani? Radden, it depends what you're looking for. I mean, all of these are going to hydrate you. All of these are fine. Again, it depends what you mean by better. If you're looking for something with the least amount of dissolved stuff in it as possible, then you're going to want to go with Aquafina. If you're going to want to go with something that probably tastes fairly good, most people do not like purified water. They don't like the taste of it. They like a little bit of mineral added back. And so then these 3 are going to be the ones that you're going to want. Various types of tap water, it's tested by different city municipalities. You can see what's dissolved in them. And most of them obviously are going to follow your health codes. But, occasionally there can be issues with stuff that is found in your water. But, you need to check online for your municipality's water test in order to be able to tell that. I can't tell everyone's. So Radden wants to say, overall, after a certain period of consumption, which one is overall best option, as in taste and possibly health? For taste, that's a personal thing. Everyone's going to have to test that on their own. I will say I find that most people do like some minerals added back to their water. So in terms of taste, you're probably going to want to go with Dasani or Ice Mountain or your tap water. Most people will be that way. In terms of health, all of these are, in my opinion, equally good. There's not one that's better than the other. They all contain water. And that's what you're looking for when you're drinking water is hydration. Here we go. I'm going to now test the Evian water. What's nice with this one, we can kind of see how our method is doing because this one says it's pH 7.2. So this one should be green, right? It should have a green color when we're done. So I'm going to go ahead and add the universal indicator. We can give a test as to what we would expect the color to be. I expect it to be green. Here we go. In goes the universal indicator. All right, here we go. There it is. One big squirt. Another big squirt. And this is probably going to be our best neutral color. What I mean by that is this is going to, it tells us right away that it's pH 7.2. So this one is kind of like our real pH control. This one, there we go. That's our control green. So we can actually compare these three now. This one's pH 7.2. So this is really close to neutral. This one looks a little more yellow to me than green. And this one looks a little more green to me than yellow. So if we were comparing these three, but the water from my tap, Evian water, and Ice Mountain, it is probably the case that this is going to be really close to pH 7. This will be below pH 7, slightly acidic, and this one would be above pH 7. My guess would be is this is going to have the most dissolved minerals, but I'm not certain about that. There's a lot of different things that's going to affect pH. Now we can do the last one, Icelandic, pH 8.4. That should be more blue than green than this, right? This is pH 7.2. 8.4, that should be a little bit, that should be up in this region. So this might have a little bit of an aqua color to it, and we can test that. Here we go, baby. Here we go. Let's test the Icelandic. It's kind of fun to have all these different bottles of water, and they're water, but there's slight differences in the additives in the water, which gives them a different color when I add the universal pH indicator. Here we go, adding the universal indicator to the Icelandic. In it goes. Oh, that's looking about the same color as the Ice Mountain to me. All right, let's give that a swirl. See what it looks like. Give that a... Ooh, that looks a bit more blue, doesn't it? Just a bit. If I can... Yeah, to me, that looks... Here, we'll get these two off here. To me, this one looks a bit more blue than green, doesn't it? That Icelandic. Sure does. Look at that beautiful blue color. It's kind of nice. It's like ice blue, huh? I agree, Phantom Gamer. Can you drink it after adding the universal indicator? You can, Radden, but if I did that, I'm guessing that the live would end in about 15 minutes. That's because one of the dyes, there's actually 4 dyes in the universal indicator. One of the dyes in the universal indicator used to be the main ingredient in X-Lax. Thanks, Alex. That's what we try to do here. I'm trying to just give you the observations, the straight up observations, and then you make the choices for yourself. But in my opinion, any one of these brands of water, including your tap water, is going to be fine to drink. As long as it doesn't have any lead in it or something like that. Let's check it out. Of course, PFAS is also a concern. I don't know if your local municipality tests that or not. What's my favorite test? All I know is I don't like the taste of Aquafina, but that's just me. It's a personal thing. So there's Aquafina. That's got an orange color. That's got pH 4 or 5. This one is actually the most pure of them. So all of these have dissolved carbon dioxide in it. This one's been purified, and there's a little bit of carbon dioxide that's going to be dissolved into any water. Just a little bit. And that little bit changes it from like pH 7 to pH 4 or 5, which is remarkable. Your Dasani, that's got like a pH of 6. My tap water is next in line. It's got like a yellow-green color. Isn't that remarkable? These are all water, and look at those different colors. This one has a pH. The Evian water has a pH of like 7, 7.4. So you can see the progression there. It's kind of pretty. Kind of pretty. Do I recommend fully filtering water to exactly pH 7? Here's the thing, Rad. You can't filter the carbon dioxide out. So the filters that you buy, they're not going to filter out the carbon dioxide. They can filter out some of the solids, but the CO2 ain't coming out. And then you can boil. You could boil the your water, and that would get the carbon dioxide out. But that's the carbon dioxide's harmless. It really is. Okay, so then we've got Ice Mountain, which is a little higher in pH, and then finally the one that's the highest in pH of all was our Icelandic. Look at all those different colors. And now what we're going to do, now we're going to see if we can even get another color. You guys are going to love this. Okay, so what do we got? Like 1, 2, 3, 4, 5, 6 different colors. And now we're going to test essential water. This is that alkaline water. Yeah, and that's exactly what it is. If you look here, it says pH. It's going to be 9.5 or higher. So that means we should expect to see like a blue. Sorry about spill a little water on here. pH 10, it should be violet. So pH 9 or 10, we should expect to see like a blue or a violet color here with essential water. Let's give it a test. All right, so we get all these off of here. It's kind of fun to look at all those different brands of water. Up goes the Essentia, and then we'll do some pH experiments just for the heck of it. All right, let's see what we got. Let's test that essential water, baby. See what it is. Yeah, I like the color of 8 too. This one is really beautiful. That's like pH. Isn't that? It just looks pretty. It looks like, I don't know. Looks like the blue crystal in Superman's ice castle or something like that. Here we go. This one's saying it's going to be pH 9.5 or higher. I'm expecting blue, like a dark blue or a violet. Let's get that universal indicator out and give it the test. Here we go. In goes our universal indicator, nice green color. In it goes. Hey, look at that, man. It's like purple. Oh, it's beautiful. Beautiful purple color. How you doing there, Chemistry Publications? Welcome aboard. Let's give this a nice shake. We are testing different bottles of water simply for pH, and we are seeing a remarkable variety in color. To recap, look at that gorgeous purple. Really beautiful. So to recap, we started with Aquafina, which has a pH. Looks like to our test, that's a pH of 4, yeah? And then the next one we tested was Dasani. That one has got a pH of about 6. And then we tested our one that's close to neutral. That's Evian water. That's like pH 7. Those are the first 3. So that covered pH 4, pH 6, pH 7. Then we tested my tap water. That's slightly acidic, right? It's got that green color, but a little bit of yellow in there. And then we tested Ice Mountain, which is a little bit more blue than green. So here's the one that's pH 7, right? You can see the Ice Mountain's got a little bit more blue in it. Yeah. And then we tested our Icelandic, which says right on the bottle, pH 8.4. And sure enough, look at the color we got. Yeah, right there, pH 8. And then finally we tested essential water, which was pH 9 or 10. All these different colors from bottles of water. Pretty remarkable. All right, let's do some experiments now. Let's do some experiments. There we go, baby. Let's do this. You guys don't like this. All right, let's get this going. Let's get this going, babe. Here we go. I put a little stir bar in there. Get the stir bar running. Get that rolling. We're going to add some water. Where's my water? Here it is. Add my water. Come on. There we go. Good little vortex going. We'll just do some pH experiments today. Come on, let's see when we get the rain or the vortex happening here. There it is. See the vortex? I can see it. There, I like that. Nice little vortex. All right, now what I'm going to do is I'm going to add some universal indicator to this vortex. Let's remind ourselves of the colors we might see. Hold on, let me shine the light on there. So this is my tap water. So I'm expecting this to appear like a green color because that's what we tested it before. Here we go. In goes the universal indicator. Got that green color, and let's see what happens, baby. Look at how it remains in the vortex. Isn't that cool? It doesn't like get spread out immediately. When it hits the bottom, it gets pushed to the side. But look at that. Why does it stay in the middle like that? Well, it's like, you know, a vortex. You know the eye of a hurricane, that's a low pressure region, right? And material moves from high to low pressure. So if you're stuck in the vortex, which is a low pressure zone, you're already in the zone you want to be, right? You're in the low pressure zone, and you're just going to kind of stay there until you get like pushed out by the stir bar on the bottom. So that's why you get that little dark color in the middle. It's kind of pretty. I'm going to do one more squirt. This one I'm going to do off to the side, okay? So I'll do it off to the side of the vortex. Here we go. Now we got kind of a cloud up there at the top that might find its way to the bottom. So yeah, we see this is like a pH 7. Now what we're going to do, you're going to love this. I'm going to start adding acid or base. So I can fiddle around with the pH just by adding acid or base, right? Right now it's pH 7, which is neutral. Now check out what happens when I start adding acid or base. I'm going to add acid first. The acid I'm going to add is hydrochloric acid. It's the same acid that's found in your stomach. Just this stuff is like hundreds of times more concentrated. Check it out. Here we go. One drop. Boom. Well, of course, I see a red color. It's concentrated in the middle because it's going to stay concentrated right in that low pressure region till it hits the bottom. Then it gets spread out. And that, boy, that's not green anymore, is it? We're down to like maybe a pH 6. Let me add another drop. You can see the red where the acid goes in, gets sucked down to the bottom. It's probably going to get like a pH maybe, there it goes, a yellow, pH maybe 6. Let's add another drop. There's another drop. So as I'm adding acid, you'll notice that the pH is getting, sorry, let me get the light on so you can see the color. As I'm adding, the pH is dropping, right? We started at 7 neutral, green, and now we're down to like pH 6. Let's do another drop. Another drop of acid. There's quite a bit of material in here. I can tell that because the pH is changing slower. So what I'm noticing is that the pH from my water is buffering the addition of acid. And what that means is that as I add a drop of acid, like I just did right there, the pH isn't changing much. And that's from the dissolved minerals in my tap water. The more, the less the pH changes on drops, the more that the system is buffered. So this is fairly well buffered. I think we're finally at like the pH 4-5 region. Let me add another drop here. Yeah, my water is really buffered. There we go. There we go, baby. Like we're on that pH 4-5 region, maybe even starting to get down to pH 3. I'm going to add 3 drops here. 1, 2, 3. That might get me to, there we go, nice cherry red color. Okay, now I'm done adding the hydrochloric acid. Now I'm going to add a base. The base I'm adding sodium hydroxide. You're going to love this. Check this out when I add some sodium hydroxide to this bad boy. All right, sodium hydroxide should neutralize the acid. Here I'm going to add 1 drop. In it goes. You can see the violet. Look at that, man. We got the rainbow. We got the rainbow, a flash of the rainbow. The reason why we have a rainbow is because there's a wide variety of pHs in the system. And that wide variety shows a wide variety of colors. And then once everything homogenizes, it looks like we're at like pH 6 right now. Let's add another drop. Another drop of base. And that's all the way to violet, man. It looks like my base is a lot more concentrated than my acid. Thank you there, Educate. Appreciate that. So now we're way up there at pH, what is that, pH 10? So very basic. Let me start adding some acid. Again, the acid I'm adding is hydrochloric acid. Same acid that's in your stomach. It's just this stuff is a lot more concentrated. It's all about that base, J4. We need some music. We need some music. Absolutely. All right, let's start adding some. Let's start adding some, I am educate. Let's start adding drops of hydrochloric acid. There's the first drop. You see the red in the middle. You see it? I can see it. There's a little thin red line. Let's add a second drop of acid. There it goes. You can see it in the middle. All right, let's add another drop. I'm trying to play around with some of these features on here. Thank you there, Educate. I'm going to add a bunch of drops. 1, 2, 3, 4, 5. Let's see what happens. We're at like pH 8 right now. Look at that. Look, it's like fire. Looks like fire at the bottom that's just kind of growing through the entire system. Very pretty. Very pretty. Hey there, Lucas. What's going on, man? Let's add a couple more drops. 1, 2, 3, 4, 5. See if we can get that down to pH like 3 or something. Yeah, that's right, Educate. So this is here. If I let me turn the light on so you can see it. There's a little stir bar down there. Here's the control knob. I'll turn it off. When I turn it on, there's a magnet inside of this thing that spins, and there's a magnet inside the flask. And so, of course, when the magnet spins on the inside, it's going to spin that little stir bar. All right, let's add some base, baby. See if we can get the rainbow. All right, we're gonna add some base. I'm gonna add 2 drops, 3 drops. See if we get the base. Here we go. 1, 2, 3. Let's see if we get the rainbow. Oh no, I added too much base. I don't think we're gonna catch it. I think it's pretty much gonna just fade to like a bluish purple. So let me go ahead and add a little bit more acid. Get it back to acidic. Thank you there, Educate. I appreciate that. Look at that gorgeous color shift. So the color shifts happen because when I add acid or base, it changes the pH, and each pH is going to be associated with a color from the indicator that I've added. All right, there is a bunch of acid. Now look, here's the different colors you see at different pH values. The pH colors follow the order of the rainbow. pH 3 is acidic, pH 4 and 5 is acidic, pH 6 is acidic, pH 7 is neutral, pH 8, 9, and 10 are basic. Right now it's very acidic, so I'm going to add some acid to, I'm going to add some base to neutralize the acid. And if I add enough base, it will go to violet. All right, Educate. Go for it. Here we go. Let's add like 3 drops here. 2 drops. Let's see what happens. 2 drops of base. Come on, man. I want to see the rainbow. I want to see it. There it is. There it is. We got all the colors in one shot. We got a little shot of the rainbow there, which is beautiful. I'm just going to add like acid and base, a whole bunch at different marks just to make it look pretty. I added acid there. Now I'm going to add some base. Now I'm going to add some acid. I'm going to slow the speed down just a bit. That's kind of fun to do sometimes too. Let's add a little more acid here. Come on, man. Come on, man. A little more acid. Look at that redness just heading through. You can also see that most of the acid stays concentrated in the middle. That's because that's a vortex there. And the center of a vortex is going to be low pressure. And material tends to stay centered in low pressure regions. So it's going to stay centered there until it like hits the bottom and gets pushed out. That takes some time. It definitely takes some time. All right, let's add a little more acid. Looks like I didn't have much. Here we go. 1, 2, 3. Let's see if we get this down to pH 3 or so. Look at that. See that red in the middle? Let's add a little bit more here in the middle. See what happens. See what happens. Yeah. Fluorantimonic acid. I don't have any of that in my basement, my friend. I think you might understand why. I don't have a hood nearby down here either, so I think we're going to skip that experiment. That's okay with you. Add a little more acid there. I spilled just a little bit. I got to get my paper towel out. Give it a little wipe here. How's everyone doing today? Doing some good science experiments today. All right, let's add 2 drops of the base. 1, 2. Let's see what happens. Too much. It went to violet pretty quickly. Let's chase it with some acid here. Oh, that looked pretty good. That was nice. Got some nice color action there. Very beautiful. All right, let's add 1 drop now. Come on, baby. Give me the rainbow. Give me the rainbow. There it is. There it is. We caught the elusive rainbow. Give me another drop there. See if we can get it more. That was cool. Beautiful. I'm doing all right there, Phantom. Thanks for joining us today. Thanks for joining us today. A little acid there. A little bit of base. Thanks there, J4A. Anybody have anything cool happen to him recently? A little bit of acid. Hit the thumbs up, please. There we go. Let's add some base. Very cool. Uh-oh, I just messed up. Ah! Something crazy's happening here. Hold on a sec. I got to figure out how to fix this. Dadgummit. I got a green screen going on. I don't know how to fix it. I got to figure this out. I was fiddling around with all the functionalities on my live, and now I'm having trouble. Let me see if I can't get this fixed. Maybe it's here. No. I'm trying, man. I'm trying. I'm trying to get the green screen off. I don't know how to do it. I'm so sorry, everybody. No, I don't want retouch on. Retouch off. Camera on, camera off. This is horrific. I'm so sorry, everybody. There we go. Let's go X. There we go. I fixed it. I figured it out. The old man figured it out. Sorry about that, everybody. Oh, man. Oh, live and you learn, don't you? There we go. Adding a little bit of acid here. Let's really jack this up. Let's get this thing going, man. Get that just spinning. Get that spinning like crazy. Yeah, it looks nice. I think the faster spin might work a little better. Let's make this really acidic. Add a bunch of acid here. There we go. And I'm going to add a little bit of... So D3, the reaction that this is simply the reaction between hydrochloric acid and sodium hydroxide. The issue is, or I should say the thing is it's being done in the presence of the universal indicator. Universal indicator is also known as rainbow indicator, and rainbow indicator displays different colors at different pH values. So when I add acid, here, we'll show you here, we'll show you the pH scale. When I add acid, it's going to shift to lower pH values. So look at your reds, oranges, and yellows. When I add base, it'll go to the blues and the violets. If it's perfectly pH balanced, it'll be neutral, which is pH 7. Now, the reaction takes time, so here we go. I'm glad you think so, Phantom. So when I add some base to this, and when I do that, the reaction is going to happen rapidly. And it looks like it's equilibrating around pH 6. Yeah, because it's got a yellow color. But intermediate between the equilibration color, you'll see a variety of colors as the acid and base is not well mixed, and they're all reacting with each other and producing a wide variety of different pH values throughout the system. Here we go. Add a little bit of base, one drop. Give me the rainbow, baby. All right, let's get a little more acid in there. That's perfectly pH balanced, pH 7. So the acid and base were neutralized. I'm now adding acid to get it to like a pH 3. And now I'm going to add, thank you there, D3. 1, 2. Add some base, see what we get. Add a little more base. That's beautiful. All right. Add some acid, get her back down at a low pH. I'm going to add 2 drops of base here. 1, 2, see what happens. See if we get the rainbow. It's really flashing quickly, isn't it? The colors. Pretty. Add another drop. I'll tell you what we'll do. Let's just add a bunch of both at the same time. Here we go. 1, 2, 3, and a drop of base. 1, 2, 3, and a drop of base. 1, 2, 3, and a drop of base. 1, 2, 3, 4, 5, 6, 7, 8, and a drop of base. All sorts of colors, man. You got it there, Kaiser. Hey, thanks there, Foul Liz. Appreciate it. Appreciate it. Glad to see you saying hello today. Seriously glad to have you on board. Let's add a couple drops here of the acid. Drop the base, baby. You got it, 9065. I probably should add. I wonder if I could play music on this thing. It'd be nice. Is there any? I don't know. It doesn't look like there's any option for me to play music. How you doing there, Mohammed? Great to have you on board. Great to have you on board. Let's add some acid here. Boom, 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 boom. Couple drops there. Couple drops of base. 2 drops. Get everything going well. Yep, I hear you. D314. We don't want that. I don't want any copyright strikes. So far, I've never had one. There we go. We got any fellow YouTubers out there? Anyone got their... Go ahead and drop your channel name in the chat so folks can check you out. It's always fun to see that. I wonder if there's any limits on how much base you can add into the solution besides the container being full. I know, I can just keep adding base. Here, I'll keep going. So I'm going to continue to add base. But the deal is once you kind of hit violet, the system maxes out. You can't I can't make it any more violet than this. And likewise on the opposite end, once it hits red, you can't get it any more red than, well, I got to get it down to that color. I'm adding acid right now, so the pH at some point is going to start dropping. At some point it's going to start dropping. At some point it's going to start dropping. Man, look at all this acid I'm having to add. There's a lot of base in there. There we go. We're finally getting the color shift. There's a lot of base in there. And I'm trying to get this to red. There we go. We're getting there. We're getting there. And right about here, I'm not going to be able to get it any more red than this. So it's kind of maxed out in terms of the acidity right now. Thank you there, Shane. Thank you there, Arcan. But you can forever switch to opposite ends of the spectrum. That's correct, Foul. Foul is, that's correct. Thank you there, Mohammed. What if I had a different molarities of solutions at the same time? Maybe that would all give off different hues. Sure would. And actually, I think that is what I'm doing. So the base that I add does have a stronger molarity than the acid that I'm adding. I can tell that. Here, watch. I'll add 1 drop of base. 1 drop of base. There it is. Let's add another. Here's 2 drops of base. 2 drops. 3 drops. 4 drops. So 4 drops got me from red to violet. Now, molarity foul, that just tells you how much acid or base is in each drop, so to speak. Okay, so I added 4 drops. That got me from red to violet. Now I'm going to add the acid. Here we go. 1 drop. If it's the same molarity, it should take 4 drops. There's the second drop. There's the third drop. There's the fourth drop. And now we're only like pH 7. There's the 5th drop. There's the 6th drop. 7th. 8th. 9th. 10th. 11th. 12th. So there we go. So it took 12 drops of the acid to go from violet to red. It only took 4 drops of the base to go from red to violet. So that tells me that the base is like 3 times more concentrated. Here we go. Let's add the base now. 1 drop. 2 drops. Man, that case only took 2, right? It only took 2. This is a very cool way to visualize a water flow. We see where each droplet affects first and how it I agree. I agree there, Foul. All right, let's add some drops of acid. Here we go. Count them out. First drop. Second drop. Third drop. Fourth drop. 5th drop. 6th drop. 7th drop. 8th drop. 9th drop. About 10 drops to get to red. Well, I got to start making dinner. I got to start making dinner for my family. That's my job. So pretty soon I'm going to flip the camera around and talk to y'all. If that's not something you want to see, now's the time to get out of here. You're going to see an old man in their basement. So if that's not something you want to see, now's the time to get on out of here. For those of you who are getting out, I appreciate the time you spent with me today. I got to do some experiments with you. Kind of fun. We do these acid-base experiments quite a bit. Sometimes I try to mix it up and do different stuff, but this is sort of the old standby. We did some experiments with water. We showed how different bottles of water, we made like a bunch of different colors all from just bottled water, which is fun, from the same indicator. All right, let's get this thing flipped around here. There we go. Turn that off, flip the camera around, and say hi to everybody. How we doing, folks? Good to see everyone today. A nice little live stream. Great to see you, Foul Liz. Thanks for hanging out with us today. Let me get my gloves off. I'm done experimenting. Thank you, Mohammed. I had a good time with you. Thanks for joining in. Any other YouTubers out there watching today? Is any science, folks? I'm doing okay there, Muhammad. I hope you're doing well. Was out doing some filming with my son last night. We got a new short coming out that I think is going to be kind of fun. I'm curious, what's the contrast like between the dangerous acid level and the dangerous base levels? Like, how far from pH neutral do both of them get? They get pretty far. So the pH just tells you the concentration of the we call them protons. So what acids do is they provide a lot of protons in water. And when you start getting like a pH, I'm going to say about like below 1, you're starting to get a pH value where the protons they're corrosive and they can chemically attack a lot of different things, including your skin. So you start getting below pH 1, things are going to get a little rough for you. On the high end, when the pH gets high, what happens is when the proton concentration drops, you form a different type of corrosive substance that's called the hydroxide ion. And the hydroxide ion, that's characteristic of bases, and that can be just as nasty, like really nasty. So you start getting your pH like above 13. That's where you're starting to get in the region where there's enough hydroxide ions around that can be very, very damaging to things like, metal, your skin, your clothing, things of that nature. So that's sort of the ends of the acid and base spectrum where things can start to get problematic, just in terms of acidity or basicity. Anybody else got any questions out there? I think it might be time for me to. Are the protons pure proton, or is it still like the same when proton is bound to another element? Foul is, I apologize. I don't think I completely understand your question. The way, when we're talking about acids, what we're referring to when we talk about protons is a hydrogen atom that has lost an electron. That becomes an H plus, a hydrogen plus ion. And those hydrogen plus ions, they attack stuff, so to speak. Other substances will grab onto those protons. They're pretty reactive things, and so things will grab onto those protons, and it changes their chemistry. So that's what we mean when we talk about proton. Foul is, it kind of is, because if you think about this, a hydrogen atom that has lost an electron is just a proton, right? So that's why we call it that. You get it? If you've had chemistry, I think you know what I'm talking about, but I'm happy to spell it out for you if you're missing something there. Yeah, that's right. It's no longer a hydrogen. We call it a hydrogen ion. Just like sodium is chemically different, like sodium metal, you throw that in water and it explodes. But you got sodium all over your body, water in your body, and it doesn't explode because it's not sodium metal, it's the sodium ion. The sodium ion has it's a different chemical, so it has different chemical properties than sodium metal. Sodium ion, I mean, we need that in our bodies. You don't want to be sticking sodium metal in your body because it'll explosively react with the water that's in your body. So ions have chemically different identities than the atoms that they come from. It's interesting, right? It's just kind of weird, but that's the way it works. It's like chlorine. A chlorine atom is a very different thing than the chloride ion. Ions refer to things that have either positive or negative charge, and the atoms, those are neutral. And the atoms, very few of them exist like just on their own, just like atoms. Many atoms end up getting connected into molecules. Any other questions before I take off for the day? Having some good discussions here. A little bit of chemistry. All right, folks. Well, thanks for hanging out today. I had a good time hanging out with you. We'll see you again next week. Usually in the weekends is when I do this. I hope to see you then. And in the meantime, all right, fellas. In the meantime, I hope you're observing the world around you and thinking about the beauty behind it, and maybe a little bit of the science too. All right, guys. We'll see you next time.